Okay, for this time, we will be looking into naming our hydrates. What are hydrates? So, hydrates, I think you're familiar with the term. When we say hydrates, we always associate it with the presence of H2O or water. So, basically, to simplify it, a hydrate is a compound in which water is chemically bound to a certain compound. So there is chemical bonding process. So that's why we call it still part of a compound. Now, how does a hydrate compound look like? Let me show you an example. This is barium chloride, and then you infuse water to barium chloride's ionic structure. So when you add 2H2O to barium chloride, its chemical formula will become still BaCl2, but you put the dot, that means there's putting into water into barium chloride structure, and there are two water molecules in one structure of your barium chloride. So when you see a chemical formula that looks like this, BaCl2.2H2O, that's your hint that you're dealing with a a hydrate compound. And if you look at the name is barium chloride. So the ionic compound's naming doesn't change. So the metal's name barium doesn't change, and chlorine has an IDE ending, so that's barium chloride. But you need to attach the name of the hydrate according to how many water molecules are bound to your barium chloride. Since there are two, then you have to attach the prefix that's a Greek prefix that's associated with two, and it's di. So you attach the prefix to the word hydrate. So it becomes barium chloride dihydrate. So di means there are two water molecules in your barium chloride. So basically, when you name hydrate compounds, all you need to do is you use Greek prefixes to determine or to present how many water molecules are chemically bound to your compound. So for this, you have magnesium sulfate. When you chemically add 7H2O, then the name will become magnesium sulfate. So nothing changes in this name because magnesium is a metal. SO4 2 minus is sulfate, so you just retain its name, it's magnesium sulfate, but there are 7H2O, 7, you use the prefix hepta for 7, so that becomes heptahydrate. Now these are some of the Greek prefixes. We'll just have the 1 up to 10 prefixes. So you use mono if there's 1, you use di if there's 2, and tri if there are 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. So please be familiar with the prefixes because we will be using these prefixes also for covalent compound later on. So these are some of the examples of hydrated compounds. So this is ammonium oxalate, NH42C2O4 dot H2O dot H2O. If there's no coefficient before water, that's understood to be 1. So you name this ammonium oxalate monohydrate. If it's CaCl2, that 2H2O, so you name first the ionic compound, that's calcium chloride, and there are two waters, so that's dihydrate. The third one, you have NaC2H3O2, which represents your sodium acetate. Acetate is a polyatomic anion. You can refer it to your list if you happen to forget about it or if you're not familiar with it. So nothing changes with the name of sodium and acetate. And since there are three waters, so that means that's trihydrate. The next one is FePO4. Fe, remember, is a metal with variable oxidation number. It can be 2 or 3. Then for us to determine what iron is that, if it's iron 2 or iron 3, we need to look at its partner phosphate, PO4. You look at the list, PO4 has a charge of 3 minus. It's fixed that PO4 is 3 minus. But since the overall chemical formula, you don't see a 3 to the subscript, that means the 3 negative of PO4 was cancelled by another 3 by Fe. So therefore, the Fe's charge in this compound is iron 3, not iron 2, because it's going to be a different chemical formula if that was iron 2. So obviously, because PO4 is 3 minus, Iron is iron 3. And of course, the name of the polyatomic anion is phosphate. So that's iron 3 phosphate. And therefore, water. So that becomes tetrahydrate. Next, the fifth one, we have CuSO4. Cu is a metal with variable oxidation number. How do we know what's the charge of Cu used in this compound? We look at the partner, SO4. Looking at your list, SO4's charge is 2 minus. That means it was also cancelled out because I don't see a 2 in copper. So copper's charge here is a 2. So I name it copper 2 sulfate. And since there are 5 water, we name it as pentahydrate. For cobalt, cobalt has also is a metal with variable oxidation number. So how do I know what's the charge of cobalt? I look at its partner, which is chlorine. Chlorine is group 7A. That means its charge is negative 1. That means since I see a 2 here and a 1 here, because there's nothing written, it's understood to be 1. So cobalt's charge is a 2. So it's named cobalt 2 chloride. There's 6 water, so that's hexahydrate. Next is magnesium sulfate, that's Mg. There's just one charge for magnesium, so therefore you just name it as magnesium. SO4, that's a 2 minus also, cancel out with a 2 plus of Mg, so you just name it as magnesium sulfate. Since there's 7 water, so you name it as heptahydrate. Next is barium and hydroxide. Barium's charge is 2 plus, OH is a negative 1. When you crisscross it, you need to put a parenthesis, BaOH2 parenthesis, dot H2O, so you name it as barium hydroxide octahydrate. Next is Na2CO3, so that's sodium and a carbonate. You crisscross the charges. Na is group 1A, so that's 1 plus. CO3, the charge is 2 minus. When you crisscross it, this is the resulting chemical formula. And so that's Na2CO3 10.10H2O. So the name is sodium carbonate decahydrate. So basically, we're recalling also how to name your ionic compounds, whether binary or ternary. And at the same time, we added how to name the hydrates, just in case you'll be dealing with compounds that have H2O bound to it. So just remember that you need to put in the Greek prefixes according to how many water molecules you have, which is indicated as a coefficient before the chemical formula of the water. So what are the Greek prefixes again? These are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So I hope you understand that. You watch out for more tutorial videos in chemistry. Thank you. Thank you.